Good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 42 is in your Cornell note that you picked up from over there, right? So thank you for getting started right away. And those of you joining us online, it's on the screen. For number 1, it says complete the square and factor, and they give us the binomial x squared plus 6x. For number 2, there's 3 parts. Part A reads square root of -4. Part B reads 3 over square root of 2. And part C is square root of 20. Number 3, it says factor by grouping, and they give us a trinomial x squared plus 10x plus 16. And number 4 reads find the inverse function, and it's written f with a little exponent of -1, then parentheses x. Then it says for the given function f of x. And then they give us the function f of x equals 2x plus 6. Alright, I'll give you guys some time for that. Ready and go. Alright, here we go. For the sake of time, I'm going to go over the warm-up. Now you should be able to have done number 3. Dare I say. Yeah, I did. So, number 3. I'll leave that for later. Let me start with number 1. Number 1 says complete the square and then factor. Now this is an Algebra 1 concept. I'm bringing it back. Here it goes. How do we complete the square here? We need to add another term. And how do we do that? We take the coefficient of the middle term. What is the coefficient? 6. We divide it by 2 and then we square it. So that becomes x squared plus 6x plus 9. That's how we complete the square. Now can we factor? Yes. Factors of 9 that add up to 6, 3 and 3. So my factors are x plus 3 times x plus 3. What's another way of writing x plus 3 times x plus 3? X plus 3 to the second power. Alright? Number 2, it says simplify. By now, we should be able to simplify this. I'll tell you now what you got for part A. What you get for part A. Yeah, make sure they got it by now. If not, slap them, please. My goodness. Yeah, this one you should have gotten 2i. How did you get that, Mr. Q? Well, remember, we can't get square roots of negative numbers, so we need to rewrite this. Square root of -1 times square root of 4. What is square root of 4? 2. And what is square root of -1? Imaginary. That's how we get the 2i. Now, I'm bringing these back because we're about to, aside from all the fun we're having already with transformations, we're going to add complex numbers. Let's go. All right, number 2b. We have 3 over square root of 2. According to the definition of fractions, the denominator has to be an integer, yes? That's not an integer, Mr. Q. Well, to change it into an integer, we're going to multiply top and bottom times the square root of 2. Times the square root of 2. This, in the numerator, we have 3 square root of 2 over. So what is 2 times 2? 4, so we get square root of 4 in the denominator. Okay. The numerator stays the same, 3 square root of 2. What is square root of 4? 2. And that's how we get an integer on the denominator. That's what we call rationalizing the rational. You know, okay, Mr. Q. Next. Square root of 20. You need to give me an estimate in decimals. You're like, oh snap. Okay, let me help you out. What number lower than 20 can you take the square root of? Let's see. Yeah, 16. Can we take the square root of 16? Yeah. Bless you. How about a number above 20? What number above 20 can we take the square root of? 25. Okay, so what you're saying is that Square root of 16 is 4. Square root of 25 is 5. That means square root of 20 has to be in between 4 and 5, which is what? 4 point something. Is that correct? Yeah, that makes sense. Okay. So how do we find that something? So here goes the process one more time. Those of you that were with me before, here it goes. I said take the middle minus the small. So what is 20 minus 16? That's 4. Over the large minus the small. What is 25 minus 16? 9. Now that we have a fraction, we can divide. 4 divided by 9 does not fit. Add a 0. 9 fits into 44 times. That's 36. Subtract. Bring down another 0, and it repeats. So that means this is 4.4 bar. Now I'm bringing this in because we're going to need it pretty soon. So we're about to also get into quadratic equations using the quadratic formula. Let's go. All right, number 3, factor by grouping. So how do we factor this? Well, 16, 10. What factors of 16 add up to 10? 2 and 8, or 8 and 2, yes? But instead of writing my factors, we need to do it by what? You're like, oh snap, I forgot about this. So you bring down the first term, x squared. The middle term, 10x, we need to split it up to these two numbers that we got. So we write what? 2x plus 8x. And then you bring down the last term, which is 16. And now we group. Now we group. We group. GCF is x, we're left with x plus 2. GCF is 8, and we're left with x plus 2. So what's the same here and here? X plus 2. And what's left over? The x and the plus 8, so that's x plus 8. Yes? Alright, so here's something new. And once again, those of you that were with me in Algebra 1, I covered some of this. I just did the practice. I didn't really get too into it because we're now in Algebra 2. Hopefully this rings a bell. Here it goes. To get the inverse function, first of all, if you notice here, the inverse function, they write it with an f and then -1 on the as an exponent, which is not an exponent, it's just a notation. So, how do we get the inverse of this? Well, step 1, we need to rewrite it to its original form. Instead of f of x, it was what? Y equals 2x plus 6. From there, we need to solve for x. So to leave x by itself, what do I do? Minus 6 minus 6. We're left with y minus 6 equals 2x. And last but not least, you divide by 2, divide by 2. Y minus 6 over 2 equals x. You're like, Mr. Q, piece of cake. Yeah, but I'm not done. Alright? So I'm pretty sure you followed up to right there, yes? Okay, here goes the next step that sometimes it comes like this. I tell people this is what makes it an inverse. And the words are coming at you that I just said, and then they just go past you like this. Here it goes again. What makes this the inverse is what I'm about to do right now. All I do is exchange the variables and rewrite it. So it's x minus 6 over 2 equals y. And now I rewrite it. Instead of y, I'm going to write f inverse of x. Here it goes again. Instead of y, what did I write? F inverse of x equals to what? To all this. X minus 6 over 2. That's how you get the inverse. Fairly simple? Yes, pretty simple. Just that you're like, I don't know what that means, but I got it, Mr. Q. All right. That's all I need. Right now we're just working on the skill. When we get to that session, which is pretty soon, hopefully you already got this part down, okay? All right, let's move on. Agenda for today, warm-up number 42, transforming functions, and your home plate is only 2 problems today. Woo, it's cool. You good, yeah? You good with only 2 problems, yeah? Okay, good. Once again, agenda for today, warm-up number 42, transforming functions, and your home plate is only 2 problems. All right? Your Nearpod code B37JT. B37JT. Those of you joining us online, you can go to nearpod.com with that code. If you're not part of our course here, then you can just follow with that code the session. All right, here we go. This weekend you had a home plate, didn't you? Yeah. All right. So make sure you turn that in on Canvas right now. And let me elaborate on this. And I'm also recording it. It's going to go on YouTube just to make sure we got it. So. Quarter 1, we're done with quarter 1. We're 1 week into quarter 2. Now, was I pretty flexible quarter 1 with assignments and grades and stuff like that? I think I was. But now it's quarter 2 and we're getting closer to the semester, so I'm going to start tightening up the screws and the nuts and bolts, take off the training wheels. So now, instead of making the deadline for home plate till 3:59, it's going to be at the end of this period. You're like, oh, that makes sense. Shouldn't that have been from the beginning? Yes. Let me repeat that again. The deadline to turn in your home plate from the weekend or the one previous night is at the end of the period. Now, according to the syllabus, I said there is no late assignments. That means I don't accept late assignments. But have I been accepting late assignments? Yes, because I was being flexible to transition you back. So, from this point forward, though, if it's late, you only get half price. So, being that I'm giving you the notice today, we're going to start with all that tomorrow. So you have today to turn in your home plate till 3:59. Okay? Thank you, Mr. Cute. You're welcome. I got you guys. All right. Y'all ready? All right, here we go. Your home plate for tonight is only these 2 problems. Only. But you can get that with your Nearpod code, right? So basically it's all about graphing quadratics and cubics and transforming them and writing the different functions already translated or transformed. But since you guys have been doing your home plate, what am I talking about? You guys got this. Let's go. So at the bottom of your Cornell notes, write the objective for today. And it reads, I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. All right, if you notice, we're still on the same concept, which is functions. So do we need a fair model? No. Okay. Do we know how to transform? Yes, we've been transforming, Mr. Keith. Do we know what parameters are? Yes, by now we should know what they are. However, for the sake of let's say somebody came in out of nowhere to my class and they haven't seen any of this, here goes again. Functions, we know what they are. Parameter. Parameter is a number. Let me repeat that again. A number. Is it a variable? No. It's a what? A number. And it transformed the original function into a newer function. And I gave you this rule. g of x equals f of x minus h plus k. Now, one thing to note, look up to the screen. Where is the h located? Inside of the parentheses. Where's the k located? Outside of the parentheses. Let me repeat that again, just to make sure we got it. H is inside the parentheses with f of x. K is outside. Okay. K. Let's start with k. What does the parameter k that's outside of the parentheses do to any function? Let's say I gave you like a Pokemon and you graph Pokemon, that's f of x. What is k going to do if it's a positive number? It's going to go what? Up. Positive, it goes upward. But what if I give you a negative number? Then it's going to go down, whatever that number may be. Okay. So if k goes up and down, that means h goes what? Side to side. Yes, that is correct. Now this is the confusing part for some of you. Let's say I wanted to substitute a number in there. If I substitute a positive number, it's going to go to the right. However, if I substitute a negative number, it's going to go to the what? Left. So watch, look up. If I substitute a negative number in here, doesn't this turn into a positive? Yes. Okay, that's the confusing part for some of you. But that's why I'm saying I need to substitute values. Substitute values. Everybody got it? All right. So, just for the sake of it, let's see what we did last week. Here it goes again. Last week we started with linears. And if you notice, these numbers, the positive 5 and the negative 2, are outside of the parentheses of f of x. The positive 5 made it go 5 steps up. The negative 2 made it go how many steps? 2 down. Okay. From there we went to a quadratic, which is a parabola. And notice in here I substituted which number in here for the first transformation? A positive 5. That means it moved it what? 5 steps to the right. And look at this red one. To get a plus 4, I needed to substitute a what? A negative 4. That's why it went to the negative direction, which is 4 to the left. This is where some of you get confused, so make sure you untie that noodle right now from your noodle. Please, pretty please. Everybody got it? All right. So, this is what I'm going to do. Let's see how you do with those two. Look at that one. For those of you watching online, see if you can do that one on your own. I'm going to pause this. All right, those of you joining us online, there's the answer on your screen. And once again, to confirm, this positive 4 is outside of the parentheses of f of x. That's why we go 4 steps up. And this negative 4 is outside of the parentheses of f of x, and we go 4 steps down. Okay. All right. So, looks like most of you, yes, we got it. Go to the next one. All right, those of you joining us online, see if you can do these translations by yourself. And I'll pause the video at this moment. You can do the same. Copy and go. Okay, once again, for those of you joining us online, there's the answer on your screen. And let me go over this for those of us here. So what do you guys notice? Well, the number is inside of the f of x, which means it's our h. It's horizontal translation. So, our original form, remember our original form has fx minus, is that correct? Oh, it's frozen, my bad. Let it go. Fx minus, is that correct? So what do I need to substitute in here to make it look like that? Positive 2, yes? I substitute it in here and it becomes this. So if it's a positive 2, it's going to move to the right. Okay. Next, what number do I need to substitute in here to make this positive 6? Yeah, a negative 6. Because negative 6 times negative is a positive. That means I'm going to go to the left. Okay? If you didn't get that, make a note for yourself. Please, pretty please, because it's going to start getting funner by the minute. Once again, this is the original. The original should read g of x equals f of and x minus with a blank, and we need to substitute values in there. Okay? Alright. So let's move on. So, let's see. So on your Cornell notes, you should have this table there, yes? Okay. So I'm going to go over this. This is what I call the anatomy of a function, of a transform function. And I bring this up because this is where I start clarifying some of your noodles, some of the questions you might have. So here we go. We still agree that we're on this general form, yes? H and K are parameters, okay? So what table did I give you? I gave you a table, example to MQ, of parent functions. So from this point forward, these functions are going to be the functions that we're going to be working with throughout the transformations. Okay? Yes? Okay, good. So, linear, and we know how they look like. So you can copy this little line like that. That's a positive, and that's a negative. That's a linear function. Quadratic, it looks like this. It's a parabola, happy face, or a parabola, sad face, or downward. A cubic function looks like this. This is the one that looks kind of weird. It looks like that. Takes a little curve going upward, and then a negative cubic should look something like this. Okay. And what is the notation? Look at for linear. F of x equals x. That's just the basics. It's what we call a parent function. That's the beginning of everything. It doesn't have anything multiplying it or being added to it. That's just a cut and dry linear function. Now look at the quadratic. Doesn't it look almost exactly the same as the linear? What is the only thing that changes? The squared, because it's a second degree. And look at the cubic. What's the only thing that changes? The cubic. So that means when we write transformed functions for all three of them, they should look the same. The only thing that's going to change is what? Is what? The degree, yes? So watch. So for this one, let me start off by writing here's my general rule again. But look how I'm going to write it. I'm going to write it like this. G of x equals f of x minus, and I'm going to leave an empty space, and then plus an empty space. Write that in your table. I'm going to do the same for the quadratic. G of x equals f of x minus, empty space, close parentheses. However, now that it's a quadratic, I'm going to do to the second power and plus blank. Now, how about the cubic? The g of x equals f of x minus, empty space, and now since it's a cubic, close parentheses to the third power, and then plus. Alright, so let's say I asked you to move the original, look at the screen, the original linear function. Look up. Picture the linear function, which is this one, f of x, and I asked you to move it according to this. It says, translate up 3 steps. Okay, does that number go inside of the parentheses or outside of the parentheses? Outside, because that's where k belongs, yes? And it's a positive 3 because it's up 3 steps. So I'm going to write here 3. Write that down, please. Now, since there's nothing here in the empty space that I left, do I really need that negative there? No. So now I can rewrite this as follows. G of x equals f of x, and then we no longer need the negative or the empty space, and I just bring down the plus 3. You're like, what? That's it? That's it. And let's see if it makes sense. To get g of x, what did we do to the original f of x? We added 3. Yes, that's moving it up. Okay, let's do the same for the quadratic. Let's see. That's it. Translate 2 steps to the right. To the right, it's a positive 2, yes? Okay, and where does that go? Outside of the parentheses or inside? So I just write a positive 2 right there, okay? Then it says 4 steps down. That's a negative 4. Where does that go? Outside, so I write it here, negative 4. But can we leave it like that? I can leave it like that, but it's kind of funky having those 2 different signs, so let's rewrite it. So this becomes g of x equals f of x minus 2 squared, and then minus 4. All right, let's see if you can do the third one by yourself. All right, check with the neighbors, see what they got. And I think Audrina's got it. I'll ask her in a little bit, so. Okay. I don't know. Yeah. Okay. All right, let's see. Who did I say? Audrina? Audrina. So 3 steps to the left. It's a negative 3. Where does that one go? Inside, yes, negative 3. 2 steps up is a positive 2, and that goes obviously outside since there's no other place. Can we rewrite that, guys? Yes. So this is g of x equals f of x plus 3 cubed, because it's a cubic, plus 2. Hands if you got that. Okay, good. All right, guys, and the reason I'm spending today doing this review with you guys, because we're done with this introduction to transformations on Wednesday, and we didn't have a pop party on Friday. There it goes again. We're done on Wednesday. We didn't have a pop party on Friday. 1 plus 1, you get that, right? Okay, good. All right. Check this out. You have space underneath, yes? At the summary section, yes? Okay. So let's extend, and let's write f of x equals x squared. And I want you to write me a function after translating that quadratic 9 steps right, 1 step down. Let's see, write that, please. Should be almost done. All right, share with me, see what they got. Okay, we got it, yes? Alright, let's see, help me out. Jessica, what do you write? G of x what? F, parentheses. I'm sorry? Minus 9. Before negative 1. So can you ever see what's missing? Yeah, the second power, don't forget it's because it's a quadratic, and minus 1. Hands if you got that. Okay. So let's do another one. F of x equals x cubed. So by now you should be, if you look at the translation, you should be able to tell what kind of function it is and what the translation is being done. So for that one, let's do 6 left and 9 down. Alright, share with the neighbors what you got, please. They're like, man, it's secure, it's flying. I know. Like Michael Jordan, let's go, let's go. Alright, I think Pamela's got it. So Pamela, G of x what? F of x plus 6 cubed minus 9. Hands if you got that. That is cool. Alright, now that we have our goggles, our transformation goggles on, that was the purpose of this. Don't write this down, look up. G of x equals f of x plus 3 squared plus 7. Tell your neighbor what kind of function it is and what is the translations being done. What kind of function and the translations. Alright, let's see. Sky, go. What kind of function? Quadratic, yes. And translation? 3 to the left and 7 up. Hands if you got that. Yeah, let's do another one. G of x equals f of x minus 1 cubed plus 3. Taking over the function and the translation. Alright, so this is a cubic, 1 to the right and 3 up. Hands if you got that. Yeah, from 1 to 5, how comfortable do you feel with these? Yeah, we got this, yes? Did that clarify enough the general rule now? Does everyone understand now that the negative is part of the rule? We're only substituting values for h and for k. K? See what I did there? Anyways, for those of you following along online, copy this one. This is a cubic function. And those of you that are here, you don't have to copy this one. Anyways, those of you online, copy that and see if you can do those translations. Alright, correct answers on the screen. The only thing that they didn't put at the end were the arrows. We need arrows at the end, but there it is. The green one, since the number is outside of the parentheses, it goes up. The red one goes down. The blue one, oh man, the blue one should have been over here. My bad. And the black one should have been on the other side. So there was a mistake right there. Whoa. Yeah, this one's on its way, but oh my goodness. Are you guys doing it with your fingers or your feet or what's look at that. There you go. Oh man, that eased my anxiety for a little bit. Alright. Anyways, we get the point. Yes? Alright, let's crank it up a notch. Behind your Cornell notes. Here we go. Write this down, please. F of x equals x cubed. Those of you watching online, copy that on your new graph paper. Alright, and here's a quick intro to cubics. Cubic functions. How do we graph that without a table? We start at -2. What is -2 times -2 times -2? That's -8. About that point. Next, -1 of x. What is -1 times -1 times -1? -1. 0, 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Those points will always be, for sure, on our graph. So make sure you get used to them. Make them your BFFs. If you go to the restroom, go to the restroom with them. So like that, they are with you all the time. There it is. And that's our f of x. Alright. So for this one, they want us to write a new function that translates the original, the parent function, how many? 3 steps to the right and 6 steps down. I want you to write your equation on your paper, the new equation for the transformed cubic function. You're like, what? It's not in the table, Mr. Q. I know it's not in the table, but you know how to write it now, right? Yeah, g of x equals what? Blah, 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 blah. Alright, so you never let them know what you're going to write for your transform function. Alright, let's see. Help me out, Lewis. F of x minus three. Close. Power 3 minus 6. Hands if you got that. That's going to be your home play, by the way. You're going to have to write an equation and graph the translation. What's the translation? 3 to the right, 6 down. So I'm going to start over here. 1, 2, 3. 1, 2, 3, 4, 5, 6. This one. 1, 2, 3. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 1, 2, 3, 4, 5, 6. Oh. And there you go. This is my g of x. Alright, from 1 to 5, how comfortable do we feel with these? Yeah, 5 fourths, 5 fourths, 5 fourths. And once again, here goes once again the home play for tonight. The home play, well, there's only 2 problems that are on the screen. You need to translate twice the quadratic, translate twice the cubic. Have a good one, guys. Enjoy your home play, and I'll see you guys tomorrow. Bye.